Hi folks, I'm Olga and let me welcome you to the episode 1 from my Basic Statistics online course. I plan to produce a number of short informative videos and hopefully these videos will be helpful for you if you want to understand some basic concepts of statistics. So, first 5 episodes, in them I will cover a couple of things. I think that usually students are expected to know some basic things from statistics when they start doing hypothesis testing or running regressions, but my teaching experience shows that it never hurts to go over these basic things to make sure everybody in the class understands this very key concept. And that's why my first episodes will be really about basic stuff like what's distribution and what's mean, mode, and median. They are also called measures of central tendency. Then I will also talk about measures of spread and descriptive statistics for 2 variables, which is correlation. So let's get started. Today I'm gonna talk about the logics or derivation of normal distribution, because I think many people are really intimidated by this term, and I hope that by the end of this video you will really understand this concept well and will be able to use it, and it will be really helping you in your study in statistics. So I think that a really good starting point for learning more about the distribution is to look at such simple thing as histogram. So look at the table on your screen, and I suggest you to focus on first 2 columns. You see that we have information about total 300 companies and they have different turnover. First column shows this different turnover by intervals. So first interval from 0 to 200 millions, second interval from 2 to 400 millions, and so on. And second column shows us how many out of total 300 companies have their turnover belonging to the interval from column 1. For example, 50 companies have their turnover from 4 to 600 million euros. Okay, and my question is how to represent this information in the form of histogram. And on the screen you see really 4 easy steps. We have to do them in order to get a histogram for this data. So step 1, we convert counts from column 2 into percentages. And the result of this operation of this step reported in column 3. If we think about total 300 companies as about 100%, then what we basically calculate is how many percent correspond to values from column 2. I also report my calculations in cells, so it should be easy for you to follow and to see, for example, that 130 companies would be 43.3% of all companies. Step 2, let's calculate widths and heights for each bar of our histogram. And width is column 4, and it's calculated as a difference between upper and lower values from turnover interval. For example, first 200 we get by subtracting 0 from 200. Next 200 we get by subtracting 200 from 400, and so on. Values for column 5 we get by dividing area by widths. For example, 43.3%, we divide them by the widths of interval to which these companies belong. So we divide by 200, and then our result is 0.217. if we think about the units, we will understand that height is a measure of density, and the units of this measure in our case is percentage per million. By comparing values in column 5, you also see that there are more companies within our first interval than in the following interval. So we see that we have 0.2% of companies belonging to every million of turnover in our first interval compared to less than 0.2 in the following intervals. And then we have steps 3 and 4 from how to draw a histogram. So let me move on to the following slide in order to show you how to do these steps. So step 3 was about drawing axes. So units for the vertical axis is percentage per million of euro, and this axis shows density. Horizontal axis units are million of euros, and we mark our values for turnover there. So step 4, what's left is to draw bars by using information from the first and the last columns of our table. And we are done. Histogram is ready. Units on the vertical axis might look strange to you, and let me try to explain them once again on a different example. So for simplicity, assume that we have 100 people and 50% of these people having their income lower from 0 to 50, and another 50% of these people they have their income higher from 50 to 100. And I also calculated widths and heights for this example. You see it on your screen. And under the table you see two graphs. Left side graph uses percentage of total as a unit of the vertical axis, and there are two equally high bars on this left side graph. But intervals for income values in our example, they have different widths. So first bar is 50 units wide and second bar is 150 units wide. We know that total area of bars in the histogram should account for 100%, and from left side graph we see that first bar, in that case, if we consider that total area is 100%, we would understand that first bar represents only 1/4 of total area, and suggests that only 25 people actually receive this lower income. But that contradicts our original data, and data from the table tells absolutely different story. We have 50-50 split. And graph to the right would be a proper histogram for our data, and it's really easy to see visually that we have two bars and each bar would correspond to 50%, and they will sum up total to 100%. So this right hand side bar actually uses density scale or height, not just a percentage, and that's why we use density scale, because otherwise our histogram would simply not be representative of the data that we originally have. And now I hope it's a bit more clear to you why we calculate and use this density measure. So let's get back to our original histogram for turnover, and I have a couple of questions to you. So imagine that what I want to do now is to split the second bar into two bars. Instead of having interval from 2 to 400 million euros on the horizontal axis, I now want to have two intervals from 2 to 3 and from 3 to 400 million euros. And green splitting line is expected to show this more graphically, more intuitively. So we know that our second bar represents 33.3% of all companies. But if we split the bar into two, how should we split this 33.3%? Think about it for a sec. Would a simple division into two be applicable? Can we reasonably assume that now each new bar will correspond to half of this 33.3%, would correspond to 16.65%. And let me ask you another similar question. What if I split first bar of the original graph into 4? Graphically it's shown with red lines. Will each of these 4 new bars be holding equal share of 43.3%? So here is the answer I suggest. No, the split of bars won't produce equally weighted in terms of total percentage new bars. The split will follow some general trend in our data. For example, in our case, it's that there are more companies with small and medium turnover than with very small and very high turnover. So if I further keep splitting my 5 original bars into smaller and smaller and smaller bars, smaller intervals, that's what I usually get, and that's very close to what we call normal distribution. Okay, so I talked about the logics of derivation of normal distribution, and I hope that now you are not afraid of this term, and I will explain in more details normal, standard normal and t-distribution in episode 5. As for the next episode, it will be about mean, mode and median, or so-called measures of central tendency. Thanks for watching and good luck with your study in statistics.